Hello everyone, welcome to our webinar today. So the subject is going to be learn how to design and code check simple to complex steel connections in minutes. My name is Farshad Purshak. I'm the solution technical manager at GRAITEC for US and Canada. Let's go on with our presentation today. So how we will create our connections and analyze and design them, we'll be using the IDE Statica connection software. So the software has several benefits that I have listed for you here. So first of all, it's easy and fast modeling. So the software comes with a graphical user interface, and it comes with different operations to create the geometry of connection, like your end plates, your shear plates, gusset plates, etc. You are not limited to just simple connections, so you can create very complicated connections in the software, although we also have the simple connections that you can do and use the software to model them. Software is a full finite element method analysis, which it covers the creation of your mesh for the connection, and as well as all of the other finite element related objects like your probably rigid links, contact elements, etc. will be automatically covered in the software. You will have access to results such as strain, stress, deformation, etc. Also, software can do code check using different country codes. So we have North American codes, we have Euro codes, and etc. that you can check all of those connection elements. It covers nonlinear material and geometry behavior. As well, IDE Statica has beam links to other software. So for example, if you have created your geometry in other software like Advanced Steel or Revit or Tekla and newly added STS2, you can actually import the geometry of the connection into IDE Statica and start to add your loads and analyze the connection. After that, you can export detailed reports on all of the results, formulations, code check formulations, etc. And also software is able to give you some sketches of the connection and drawings. So let's jump into the software. So I will do a presentation directly here from the software. So I will open the software and let's continue on there. Okay, I have opened the IDE Statica connection design software. So we are at the first page. So as you see here on the left side, we have some standard tools and menu options here. So to create a new project, you can open your old projects. If you want to change the units, it's going to be from here, and also other preferences that you can change, like background color and etc. To start a new project in IDE Statica, you have several ways of doing it. So the first one is you can actually start with one of these templates here. So we have around 350 templates here for you that you can start your modeling. Like here you have the main category, like beam to column, beam to beam, bracings, base plates, etc. And each of those will have some subcategories here. So for example, I can go click here, and here you can select any of those templates and any one of those which is closer to your project. And if I click create project here, we can actually create that connection there. So you can start from these templates, and there's no limitation later on. If you start from here, you can change or modify the connection. You can add or remove bolts, welds, plates, etc. So it's going to help you to actually start the project faster. The other way of starting a project is importing your geometry from other software. So as I mentioned, from other steel connection detailing software like Advanced Steel or Tekla, Revit, etc. And finally, if you cannot find your connection here, you can always start from a blank project. So this is going to give you the option to add your members one by one, and then after that, add the connection components. As you see here, also you can select some default values for steel, bolts, weld, etc., which this connection will be created based on those default values. And here we have the code check of all of those countries that we mentioned here. So based on the code that you want, you can just select, for example, in this case, I will select Canadian code. And as you see, we have two versions of CSA, a 1619 and a 1614 that you can select. So the connection will be code checked based on that standard. So for example, here I will start with one of these moment connections from the template here, and we can click Create Project. So now software will create this connection for us, and here, as you see, we are in the main modeling window of software. So first of all, the main user interface, as you see here, it's a 3D rendered shape, so you can rotate, zoom in, zoom out. You also have some view controls here to rotate, or you can also select different types of view here. So the first one here is going to be your a mode that is going to show you the connection components. Then we have a transparent mode that is going to make it easier for you to see all of the cuts and welds, bolts, etc. And finally, you can have the full rendered option there. Here on top, as you see, we have all of our tools to create our models, apply our loads, add operations or models, as you see there. And we are in Design tab, actually. So Design tab is the place that you will create the geometry. And after that, we will move on to Check tab to check the results and create our reports. Finally, we have also another tab here, which is called Materials. In case of adding new customized material or customized bolts or anchors, etc., you can go there and add your customized elements there. So just to show you like an overview of what kind of tools we have here. So first of all, you are not limited to just one connection per file here. So here my file is untitled, but I can easily go and either create a copy of this connection by clicking on copy. And as you see, it's going to be added there. Or you can even add a new connection to the same file. So this is going to make it easier for you if you want to compare models, let's say adding or removing a bolt, what's going to be the effect of that bolt on the connection behavior. So, and you can always select the current project from there. Then here we have the captions for the members. So here, as you see in this connection, I have two members. Member B is the beam and C is the column. So you can either remove them or add them. We also have captions for each plate that creates that specific element. So this is going to help you when you want to model and create openings or adding welds, etc. It can be based on these plates, as you see there. And finally, we have our local coordinate system for each element that you see there. So all of the rotations and offsets for each member will be based on the local coordinate system. From these tools, you can always add screenshots and create screenshots. You can save them as a PNG, JPEG format. You can also save them into your final report. So these screenshots can be either from the direct geometry or can be also from results. Here we have a connection library tool. This is interesting. So as you remember, we had some standard templates at the beginning. But if there's a project that you always have need to model actually those projects and the geometry is similar, you can just model it once and then you can save it in our libraries there. Then it's going to be saved on your model or on your hard drive, and you can always start off from that template. So it's going to be a similar template as our starter templates, but it's going to be based on your projects. We have the code setup option here. So as you see here, we have a detailing check. So by default, it's checked. So software will also check for some detailing errors like bolt distancing, edge distancing, etc. Also, you have access here to all of the resistance factors for steel design. And finally, here you have access to other parameters which control the mesh size, number of iterations, etc., etc. So you don't need to go there all the time. So all of the default values will be okay. So we just click OK. So then we can click on calculate, and actually software can start the calculate on this connection. So basically, if you're using a template, you can just create the geometry, apply your loads, and if you click on calculate, it's going to start the calculation. So it can take just minutes for you to create this the connection and get your results. But here I would like to mention more advanced tools as well here that we have in the software. So we also have a tool here which can be very useful, which is called pre-design. So you can actually ask the software to pre-design this connection for you, and it's going to be based on the bending resistance of the beam. So for example, if I assume that here our beam will, we want to design the connection actually for 90% of the resistance, moment resistance of that beam, I can put 90 there, click Save. And now I can actually ask for a pre-design from here. And as you see, software will try to match my connection components with that 90%. Or you can do also go and use it to economize the connection. Like I can go there and add like 20%, which is going to be a lighter connection. Click Save. And I can ask for another pre-design. And as you see, it's going to match the connection capacity to my 20% that I input. So you can always apply loads to your connections. We have two ways of that here. So you can either import them from Excel sheet and also export your loads and load combinations. And also you can import them from other analysis software. So 3D finite element analysis software. You can have your nodal forces imported inside IDEA Statica. Or here we have in load effects, which is called LE1. I have just one right now on this template, which is called LE1. And using this table, you can actually go on and input your values. By the way, I am in imperial units now, but if you want to change it, you can just simply go there to units and change it to a metric, as you see there, and click apply. So all will be applied. By the way, you can also go one by one and change them if you want to change them individually. So I will just go back to model, and if we go to the loads, you will see that now we have metric units. So in any case, you can directly type also your forces here. For example, if I want to apply an actual force to my beam element here, I can simply go there and let's say like add 5 kilonewton actual load, and that's going to be applied like that there. So if you want to add more load combinations, let's say we want to study the connection under different load combinations, you can always click here. A new load combination will be added. And now, for example, I can study this connection under, let's say, 20 kilonewton of actual load, as you see there. So software will run through all of those load combinations, and it's going to give you the results for each of them. And as well, it's going to let you know which one is the most controlling case. In terms of other modeling tools in the software, so all of the entities that we have in this connection are listed here. So the first one are our members. So member C is the column. So if you click on that, it's going to be highlighted, and you will see all of its properties here on the right side. And same thing for my beam here, which is member B. And if you want to modify the section, you can simply go and click there. And here you can see the current section. If you want to change it, you click there. And here you will have access to full library of sections that you can go on and select and assign it to your element there. Same thing for the material. I can either access the standard library of material types, or we also have an option here that you can define customized material. So let's say if you want to analyze an aluminum connection or any other material, well, because the software is a finite element solution, it's okay. You can just define a customized material, and you can still run your analysis. We also have other tools here for replacing the elements. So for example, here, if I go to side view, and let's go to beam, member B, you see that I have a 10 degrees of pitch here. So if you want to change it, you can just click and let's change it to 20 degrees, and there you go. So you can change the orientation in 3 directions. And also you can offset the member on top, bottom, left, or right using these offset values that you see there. So for example, if I want to move it back, I will just put 10, enter, and there you go. It's going to automatically also adjust all of the other operations that you have there. The other part of our model here are basically our operations. These are the operations that it's going to help you with your modeling, you know, like at the beginning we talked about fast and easy modeling. These are the operations that they will help you. For example, here in this model, I have a cut operation. If I click on that, you will see that it has some properties. If I remove it for now, you will see that the cut is not there. I have just one column, which is called C. But using this operation, actually, I'm asking the software to cut my member C, which is the column, by member B. So that's why we have this slope here. And we have different types of cuts. So you can cut it by bounding box, surface all around, and etc. And the nice thing here is, like for complicated cuts, let's say cutting pipes or circular HSS sections, etc., using the surface cut, software will automatically perform the cut for you. Then you have other parameters here, like you can decide on which plane you want to cut your column. Here also I have an access to just extend this offset here. So here I have 25. I can make it 60 millimeters. And as you see there now, I have a 60 millimeter offset there. So like this was like the cut operation. We also have our end plate operation in this connection, which is just one operation. If I remove it, you will see that it's not there anymore. I will add it back. And for end plate operations, you see we have the same properties. So our end plate will be connected to member B. Actually, you can have two members connected to the same end plate. And the main member is the column here, member C. Then you can assign the material of the end plate, the thickness. Here you can select if it's just going to be bolted, or with just one selection, I can assign a weld around it. Then you have control also to all of the dimensions there. So for example, if I want to change the dimension of my base plate, as you see here, it's going to be measured from the flange of the element. So now I have 5 millimeters here at the bottom, which is here. So if we want to extend that, I can go there and put like 25 millimeters. And there you go. So it's going to extend the end plate there. So you have control on size, thickness, dimensions, etc. And here we have our bolts. So in this connection, we have like 4 bolts. You see the grade there. If you want to change it, you can click there. Access the full material and bolt grades that you can assign to your model. And here we have the control options to location of those bolts. So here, as you see, like from top, I have minus 51, okay? And the other one is times 0, so it doesn't count. But let's say if I want to another one, I can just type another minus 50 to add another row of bolts here. Okay, which is going to be distancing of 50 millimeter. So removing and adding bolts are also simple from here. You have control on all of those locations. And finally here in the end plate operation, I have my welds. So you have control on the welds. We have different types of welds. So single fillet, double fillet, we have a butt weld, and we can also remove the weld. So in this case, if I want to remove the weld from the flange, I can just simply click there. And you see here, we don't have any welds anymore for the flange, or I can just put it back like that, okay? And finally, we have also stiffeners here, which is again another operation here. I can click on them. I can remove them just to see, there you go, it's not there, and I can add them. And similarly, their properties are here. So they're gonna be on member C, the column, related to member B. So it's going to automatically follow your flanges, and then you can decide on where do you want to put those those stiffeners, thickness, material. You can actually offset them up and down. You can add slopes. So you have all of the controls here on those stiffeners. You can also do like very special operations here that maybe it's not even possible to do in other connection software. Like let's say if you want to add some openings inside your stiffeners, okay? So in this case, I can just select my stiffener, go to editor, and here, let's say I want to add an opening like this. You can have different types or shapes. Let's go circle, and I can add the coordinates of, let's say, 40 millimeters and the diameter of 20 millimeters, and click OK. So as you see there, software will automatically add those holes inside the stiffeners, and these are going to be actually included in your calculation. So in this model, we just saw 3 operations, but we have so many of them here. Actually, if you click, you will see that like this one, the cut, we already saw it. Stiffeners, we saw it. But you can add wideners, you can add ribs, you can add any kind of openings or notches inside the elements. And also other operations like splices, gussets, shear plates, etc. can be added to your model using these operations automatically. So we covered briefly the modeling part of the software. Now let's go and check some results. So we can run the analysis on this model actually. So I will just click on calculate. So the calculation will be started, and as you see, it's going through some iterations because it's a nonlinear analysis. And there you go. The calculation is done here, and I have some results. So first of all, checking these colors here, they follow the traffic light philosophy. So the elements that they are red, they are not passing the code check. The green ones are passing the code check and are taking like forces or stresses. And as well, we have some gray elements here, which tells that they are not taking so high forces. So if you want to economize on your connection, probably you can go and work on those gray elements to make the connection a bit more economical. Also here on the top left corner, we can see the results. So plates are overstressed, 0.3%. Our bolts also like around 2.2% overstressed, actually these bolts there. And finally, our welds are 38% overstressed. So basically the welds that they are red here, they are not passing the code check and they are overstressed. So to see more results, I can click on check. And now we have access to more results. Like first of all, I can check my strain or plastic strain. So you see the value there. So we have plasticity here. They are under 5% in these areas. But at some places, we have also red, as you see there, plasticity here in the plate. Then I can check my stress distribution. Let us activate the mesh. There you go. So we can see the mesh as well. So as I mentioned earlier, like the software will take care of all of the holes, the mesh around them, all of the rigid links, the contact elements, etc. will be automatically applied to the model here. Then I can also check my bolt forces. You click there. So these are the actual forces in each bolt, as you see with the values. We can see the stresses in contact regions. So here we expect the contact between the end plate and the flange of the column, and you can see the values there. And also there is some contact here as well because of the prying action between those plates, which is happening. And finally here I can also check the deformed shape of structure or connection. Click there, and there you go. This is going to be, if I go to side view, this is the formed shape of that connection. You have access also to scale that deformation. I can make it smaller or larger, as you see there. So we also have more results here on the right side. So I can actually go into the plates one by one in this model. So they are listed here, all of the plates. I can see their controlling load case. And here I can see the maximum elastic stress, strain, plastic strain, et cetera, which is happening for each of them. So I can just go on and I will see the 2D view of that plate. So we can study even better what's happening and where it is happening here. And in this case, we see this X here, which is telling us that the end plate is not passing the check that software is doing. We have the same table for the bolts. So in this connection, we had 6 bolts, which are listed here and numbered down there. And each bolt, you will see the status. So 2 of the bolts are not passing, B1 and B2. And you see their tension, the shear, bearing force, resistance. And as well here, you see the workload ratio for tension, shear, and combine for each of those bolts. If you want to go even more into detail, like to see how software is calculating those percentages, you can click here on the plus. And here it's going to bring up the formulation. So we have selected CSA 1619. It's going to show you the clause number, the formulation, and the parameters that software is using to check that specific bolt. So we do tension checks, we do shear, bearing, interaction, and etc. for each bolt separately. So I can actually go and study them one by one, as you see there. And finally, we have the results for welds. So if I click there, it's going to be the new table here. And here you can just select and go through the welds and see the stress distribution, shear, perpendicular, parallel stress, etc. on the lengths of the weld. So here, for example, I can just select there. So this weld that I've selected is going to be highlighted by orange. And here I can see the stress distribution along the weld, which is happening on that weld. And software will also check for the weld resistance. So as you see here, some of the welds are not passing there. So I see the X mark. You can just click plus. And again, similar to bolts, you can check the formulation that software is using to code check that weld. So this was mostly for connections. Just to let you know, we also have base plate design in IDEA Statica. So I will try to show it to you here. So let's go back to my project. I will start a new one. And let's select a base plate from our template. So let's go actually with this one. Okay. Click Create Project. So base plate itself is an operation, as you see here, PP1. If I click on that. So similar to other operations, you have control on the shape of the base plate, thickness, material, etc. And as well, here at the bottom, you can define your anchors. We have different options for the anchors on how to transfer the shear force. So it can be friction, shear locks, sliding, etc. You can define the sliding. So it can be a direct contact between the base plate and concrete. You can have a mortar, or you can even add a gap, as you see there. Okay, so let's just go back to mortar. So yeah, this is like on how you can also create like base plate connections there. So I can also show you like some results on that. So let's actually go and select another base plate model. So for example, a simple one like that, I will create the project. There you go. And again, as you see, we have the base plate operation here. Everything is defined, even the concrete material, the anchors, lengths, etc. And if I click on calculate, it's going to start to calculate this base plate. Well, in this case, everything is passing, so we don't have any red elements. And in terms of checking, you will have some extra results. For example, you can have the concrete check. So it's going to check the uniform stress coming from the base plate over the concrete and the limit there. You can also see the stresses in concrete. As you see here, this is going to be the concentration of stress. And similar to other ones, you can have also the mesh. You can see the deformed shape, etc., as you see here. And now, because I have anchors in this connection, you can also have the results for anchors. You click there. And now you can go one by one through the anchors. You can see their internal forces, their load ratio, and as well, if I click there, you will see that it's going to perform some checks based on 823 and etc. to code check the anchors, as you see there. As well for concrete block, you will have it there. Let's just move it away. Okay, so it's going to be based on a 16 and 823 to calculate the allowable stress on concrete. So this was like some results on as well the base plates. And if you want to also create reports, you can just click on report. And here you will have the option to control what types of content you want in the report. So you can either go here to select what you want to see, and as well here, for example, I can have like explanations. I need my formulas in my report. Let's do cost estimate. Let's say we want bill of material and drawings as well, okay? And we can click on generate, and it's going to generate the full report. There you go. So the report will contain some information about the geometry. You will have some screenshots from geometry, some properties of the loads, foundation, and here you will have some detailed results on each element and the properties. Here we have a screenshot of results. And finally here, if you go down, you will have the detailed formulation for each anchor or weld in this case that software has checked, because I asked for formulas. So I have them in my report there. And finally, if I go down here, you will have the bill of material. So it's going to give you like the lengths, welds, etc., and some drawings here based on the project that you're doing. And this report can be exported as a Word document, a PDF, or also as a DXF, which will contain the drawings of the plates that you have in this project. So this was a brief overview of the software and the tools and how you can use it. So let's go back to our slides. Okay, so let's.
Okay, so do we have any questions in the chat box? Any questions that you guys have, you can drop them in the chat box. And Farshad, while we wait for some of those questions, I've got a question for you. If someone is interested in a demo, how do they reach out?
Yeah, sure. So if they want like a full demo, there's no problem. They can always email us. So our email is support.canada@graitec.com. And for US clients, it can be support.us@graitec.com. So let us know either for your questions, like technical questions, or if you want a trial or you want a demo, we will be able to help.
Fantastic. I put those emails in the chat box for you guys. So if you are interested, you can reach out there. All right. And as we wait for some questions here, is there a common question that you get, Farshad, from anyone who does a demo on this?
Yeah, one of the common questions is like, what can be the main or major differences between Ideastatica and other competitors, like for connection design or like doing a hand calc? One of them that most of our clients really like is there's almost like no limitation on geometry of connection. So you can create any type of connection in the software. So very complicated connections that you cannot even imagine doing them by hand. You can create in IdeaStatica. And as well, the detailed results part, you know, like you can get your deformation, you can get your stresses, you know. Sometimes we need to do like some buckling checks, you know. We also have the elastic buckling in the software for thin wall sections. So that is also a good feature. The other part is the buildings that I mentioned like briefly in the presentation. So, well, in this webinar, I showed how to create the geometry yourself in the software using the user interface. But if in your workflow, like you already have the geometry in other steel detailing software, like Advanced Steel or others, we have a direct link that you can import either the connections one by one individually, or we also have a batch import. So you can actually select all of your connections in the steel structure and import them at once into IdeaStatica. So yeah, these are like basically main benefits of the software over other software.
Awesome. Pascal has a question for us. He says, is this the same as Advanced Design Connection?
That's a good question. So yes, Advanced Design Connection, before IdeaStatica takeover, so we had Advanced Design Connection. So it is the same software, okay? So it's just change of branding. So before around 2020, the branding was Advanced Design Connection. And now after that, they changed the branding. So now they are just using IdeaStatica. But originally, they're basically same software.